So once we've determined all of our volumetric properties for each of our trial blends, we've got to estimate those properties to 4% air voids by manipulating the liquid asphalt content. The way we're going to do this is by utilizing deltas. So we've got to calculate the delta VTM, the delta PB, which is delta binder, delta VMA, which has two different formulas depending on where our VTM finished up in the trial blend. We're going to select the formula that's appropriate for that blend. So when we're estimating the properties at 4%, the VMA is going to be equal to the VMA plus the delta VMA. So here's our summary of tested and estimated properties. Again, we had 5.5% liquid in each of our trial blends. These are the air voids that we got at each one of these. You're going to go through and you're going to actually perform the deltas, do the delta calculations, and apply them during the math portion. But once this is complete, we're going to actually calculate what our estimated asphalt content will be for each of the blends by just manipulating the liquid. We're not changing the gradation, we're only changing the liquid. So let's take a look at blend 1. Again, blend 1 was our virgin mix. We finished up with 4.7% air voids. To get that down to 4.0, which is what we want to look at, so these are all apples to apples, we're going to have to tighten that mix up, right? So to get from 4.7 to 4.0, we're going to have to raise asphalt to help tighten that mix up. So as you can see, we have moved from 5.5 up to 5.78. So that makes sense. We've had to add liquid to get this 4.7 down to 4.0. When we did that, that changed our estimated VMA, not a whole lot, because remember, manipulating liquid really doesn't change VMA a lot. Gradation changes are what really makes VMA change. So even though we're adding almost 3/10 of liquid, we only changed the VMA about 1/10. It went from 16.9 to 16.8. And then our estimated percent GMM at an initial is 89. Which is fine. We're right at the max, but again, it's not a specification in Virginia any longer. Blend 2, we were 2.4 on the air voids in our trial blends. Now that's pretty tight. So we've got to lower asphalt to get our air voids up to 4%. So that's exactly what's happened. After applying our deltas, we finished with a 4.86% liquid. That didn't change our VMA a lot. We went from 15.3 to 15.1, and then we went to an 88.4 on our percent GMM at an initial. Finally, our blend 3, we were already pretty close to 4%. We got a 3.7 at InDesign, so we're having to drop just a little bit of liquid, and as you can see, it did drop just a little over 1/10 to get us to 4%. Our estimated VMA stayed the same at 16.2, and our estimated GMM at initial is 87.7. So would this meet VDOT specifications for volumetrics? Well, blend 1 absolutely does. It looks like we've got plenty of liquid in it. We've got estimated VMA of 16.8, which is well above the minimum. And we've got the percent GMM. I'm not super concerned about that. Blend 2, much lower asphalt, 4.86. There's not a minimum asphalt for an SM12.5. There is an estimated VMA of 15.1, which is low. Blend 3 is a 538, or just call it a 5.4. Got a VMA of 16.2, which is well above your 15. So do these meet VDOT specifications? Yes, they do. So how do we select which one we want? Again, here are all 3 of the designs posted on or plotted. Their gradations plotted on the Power 45. And what if all 3 trial blends meet the design requirements? This is something that happens with most designs, usually at least 2, and sometimes all 3 of them do work. Well, it's economics. Which mix is going to cost more? Which mix is going to work best? A lot of mixes that we're able to make and work in the lab don't necessarily work in the field. So let's go back and look at these. Blend 1 has a fairly significantly high asphalt content of 5.8 for a 12.5 mix. That's a fairly rich SM 12.5. May be challenging to get the work with a liquid asphalt content that high. It's going to be a fairly expensive mix to make. One thing I'll point out too, this estimated VMA of 16.8, really high VMA is not always a great thing. That means that's the void space that's within the aggregate if you pull all of the asphalt out. This may be more challenging to get density because we still have the same density spec to get in the field. So a really high VMA may pose some challenges for our field technicians. Blend 2, the 4.86 asphalt, is a little low. You may be hard pressed to get that design approved with an asphalt content that low. Even more concerning, the 15.1 VMA is right at the top or right at the bottom side of that minimum range. One thing that I can, from experience, you'll learn that VMA will typically drop 0.5% from design to production. So once we get this mix into production, it would be not unusual at all for that VMA to drop to 14.5, 14.6. Now we're out of specification. So blend 3, we're at about a 5.4, which seems like a pretty good target for a 12.5 mix. The estimated VMA is 16.2, which is really good. It's solid. If it drops 0.5%, we're still well above our 15% minimum. So in this case, we're going to choose blend 3. So now once we've selected a trial blend, we know which one we want. We want to really hone in on what is that target asphalt content, or what should it be. So the next portion that we do, the next part of our design process, is a selection of a design asphalt content. So we've done these 3 steps now. We've selected our materials that Danny and Scott took you through. We've tested all of them. We've run our consensus properties. We've come up with a design aggregate structure. We've selected blend 3, or trial blend 3 as our mix that we're going to use. Now we have to basically formalize what's that asphalt content going to be. What is the design binder content? So when we do this, specimens are compacted at varying asphalt binder contents. We're going to do 1 at the target, which in this case was 5.4. We're going to do 1 at plus and minus 0.5%, so basically 5.4 plus 0.5%, 5.4 minus 0.5%. And we're also going to do 1 at plus an entire percent, so 1 at 6.4. So here are our batches at 4.9, 5.4, which is our target for the design, 5.9, and 6.4. We're going to do 3 gyratory specimens on each of these. We're also going to do our 2 rices on each of these as well. Depending on what district you're in some cases you can take the rice at the target and back calculate so you don't have varying correction factors when you figure your effective specific gravities, but by spec it is 2 rices per each of these samples and 3 gyratory specimens per each of these asphalt contents. So here is what a compaction chart looks like when you're doing a varying AC analysis. If you remember from the trial blends, they were kind of all over the place and over top of each other. Well, these should be parallel to one another because the gradation is not changing. This is one trial blend with 4 different asphalt contents. And as you can see, we steadily pick up in density as we move up in asphalt content. So this makes sense. So here's our summary after running a varying AC analysis. We end up at 4% air voids. We have a VMA of 16.1, which is great, well above that 15% minimum. Even after it drops 0.5%, we're going to be in good shape when we get into production. The VFA is split in the middle right of the VFA criteria. Our FA ratio is 1.1. As long as our dust stays manageable, that'll be fine. We've got a percent GMM of in initial at 87.7. Again, that's our tenderness check. We're well under the 89. Also, that's not a spec any longer in Virginia, but it's just interesting to see to give you an idea if there's some potential for tenderness. And then the GMM at Nmax, we don't utilize that any longer. Again, you would have to compact to like 110, 125% gyrations to even do that now. We'd no longer do that in Virginia. So this is what some of your reports may look like when you do your report printing from your software. I think these also come off of Pine Pave. If you're in a Pine gyratory compactor, this comes with your machine and you can print these right up. These are some of the graphs that are expected as a technician you have to turn in to VDOT for approval with your mix design. Again, this is just another shot of and some of the designs, I think it does require in Section 211 that you turn in a gyratory compaction curve as well. So that's why that's up here as well. If you have any further questions, please see your proctor in your classroom.